Hello and welcome to Ikasan Online Tutorials. My name is Michael Stewart and I'm a core developer on the Ikasan Enterprise Integration Platform. And today I'm going to be providing a short tutorial relating to the Ikasan Hospital Service. The Ikasan Hospital Service provides Ikasan users with the ability to view and understand errors that have occurred on the Ikasan Enterprise Service bus. Depending upon the categorization of the error, the user is able to remediate the error by resubmitting messages that have been excluded. Errors within Ikasan are broadly categorized into two types of errors. Firstly, there are technical errors. Technical errors are considered to be transient, and as such, when one occurs, Ikasan will log the error to the error reporting component of the hospital service, and then will roll back and attempt to process the message again. Ikasan can be configured to retry a fixed number of times or indefinitely. If configured to retry for a fixed number of times, Ikasan, upon exhausting the number of retries, will stop the processing flow and flag it into an error state, and notify the monitoring service of the error that has occurred. The second broad categorization of errors within Ikasan are those that are considered business errors. Business errors typically occur when an Ikasan module is unable to process a message that it has received, perhaps due to missing static data it is trying to retrieve from the mapping service, or due to a validation issue associated with the data that has been provided. Generally, business errors are deemed to be repairable. With this in mind, Ikasan excludes messages associated with the business exceptions. These excluded messages can be viewed via the Ikasan dashboard along with the error that caused the exclusion. Ikasan users are then able to resubmit the excluded messages once the underlying business exception has been remediated. Alternatively, users can choose to ignore excluded messages. All details of user actions are recorded in order to provide an audit trail of actions taken and can be linked back to the problem management systems. As previously mentioned, Ikasan broadly categorizes two different types of exceptions that may occur within the system. The first categorization relates to technical errors. So, as I've mentioned, technical errors are typically transient. I want to outline what might be a few examples of sort of technical errors we might expect to see that would be transient in their nature. For example, we might need to call a REST service from within an Ikasan component to enrich some data, for example, from a broker. Now, that broker might make its REST call, and that REST service might be unavailable for some reason. It might be a network issue. The REST service itself, the process that's exposing that REST service, might be down for whatever reason. So what we can do is we can get Ikasan in that particular case to retry until that service becomes available. It could also apply to a database, so a database might be unavailable for a period of time. There are various technical components within an enterprise architecture that might be temporarily unavailable. And we want to be able to tell Ikasan to retry in order to start to process again when that external component or system becomes available. So as you can see here, what we're looking at is the first type of configuration that allows us to retry when one of those particular types of exceptions have been encountered. So you can see here we've got two types of exceptions configured. The first one being an endpoint exception. So as we know, an endpoint exception is typically associated with an Ikasan endpoint. An endpoint might be a producer or it could even be a broker. We can have some custom exceptions as well. So the second exception I've got configured there is a HTTP exception that's associated with a broker. For the first one, I basically said the endpoint exception should retry every 5,000 milliseconds or 5 seconds. And because I've configured the max retries to be -1, that will retry indefinitely. So when it retries, it puts the Ikasan flow into a recovering state, and periodically the recovery manager associated with that flow retries based on the interval that I've defined there. Now the second exception, the HTTP exception, which is a custom exception, it has been configured to retry every 10 seconds, but it's only going to retry a maximum of 10 times. When those 10 times have been encountered or completed, and if we've unsuccessfully managed to reconnect to our HTTP endpoint, the flow will go into a stopped in error state, and the Ikasan monitoring service will send a notification to any interested parties that that particular flow has gone into error. So for example, if you've got some kind of monitoring dashboard that is listening for notifications from the Ikasan monitoring service, they will be notified, and that could be raised up to a system operator and the appropriate team notified of that particular flow going into an error state. Similarly, for technical exceptions that are transient, we can also configure exceptions to retry based on a cron schedule rather than a millisecond offset. So you can see here that I've taken the same two exceptions from the previous example. In this case, I've defined two cron expressions that will provide the retry interval for this particular error scenario that we've encountered. So you can see the first one for the endpoint exception will retry indefinitely at a period of every 30 seconds. And the second HTTP exception retries on an interval of every 10 seconds for a maximum of 10 retries. And once again, as in the previous example, if our 10 retries have been exceeded, the flow that is processing that particular component will go into a stopped in error state, and the monitoring service will be notified. The second broad exception type that we might encounter in Ikasan are considered to be business exceptions. And we want the data associated with the business exception to be excluded. As I've stated previously, when something gets excluded or a business message gets excluded from within the Ikasan Enterprise Service bus, is effectively parked in the hospital service, and users can search for those particular events and see what has been excluded. Now, why might we want to exclude something? So let's say we've received a packet of XML on our flow, on our component that's actually enriching that XML with some other kinds of data that might be relevant to something downstream relating to that data. For example, we might receive an ISIN that represents an asset that we're trading in a financial environment. And we might need to take that ISIN and we might need to enrich it with other financial identifiers that are relevant to downstream systems. So we might make a call to a third-party system requesting those other financial identifiers that are relevant for that ISIN. Now, perhaps that particular asset does not reside in our asset mastering system yet, and we need to engage with another team to provide that asset or enrich that asset in their system so that when we resubmit that excluded message and our flow or the component within that flow attempts to enrich the asset data with those extra financial identifiers, that data will be available in the third-party system, and the component will successfully enrich the XML data before sending it to a downstream system. So it's a way of basically identifying an issue, and giving us an opportunity to still have the data hit its intended target once we've engaged the third-party teams to enrich or provide us with the data within their system that's necessary. So in order to configure an exception type that will be excluded, it's quite simple. We've got this particular configuration that we put in our Ikasan application.properties file. And it's once again a collection of excluded classes. So anytime that we hit any of these exception types at our component level, so for example, a transformation exception or a custom exception that I've created here, which is a business validator exception, if those particular exceptions are encountered by the Ikasan Enterprise Service Bus, the events associated with that particular exception will be parked in the hospital service and allow for users to remediate the external data or whatever is necessary in order to make that business data flow. And now moving on to a demonstration of the Ikasan Hospital Service within the Ikasan dashboard. So I've navigated to the dashboard that I got running locally on my machine. I'm going to log in using the default admin username and password. There's a couple of modules here of interest that I've deployed into this environment. The first one we're going to look at is the message generator. The message generator is a very, very simple Ikasan module with one flow, and all it does is produce sample trade messages. The messages are very simple XML format that I've made up, and they contain some sample generated data that's random in its nature, representing trades. The second module I've deployed into this environment is a module called Murex Trade. And that's a module that is mocking some behavior related to Murex, which is a common middle office system found in financial environments. And this flow is simply consuming from a source message that the trade generator publishes onto via a JMS consumer. It's transforming that trade message into a different format, and then we have this component here which is of interest to us. This component, if I look at the configuration, allows us to configure it to throw exceptions of certain types that will either be excluded, cause the flow to go into recovery, or cause the flow to go stopped in error. So as we've seen in the previous part of this particular tutorial, you're able to configure certain exception types that will either exclude, recover, or those that aren't configured will by default put the flow into a stopped state. So that's the default behavior. So in order to just demonstrate how this works, the first thing I'm going to do, we're just going to look at some data flowing through this particular flow. So what I'm going to do is I'm going to set up a wiretap on this component here. Wiretap, as we've seen in other tutorials relating to wiretaps, is simply the way that we can capture data on the wire for the purposes of tracking our data throughout the bus. And that's useful for all kinds of use cases within an enterprise service bus, but the main one being the ability to track data throughout the entire system. So we've added a wiretap. This flows in a running state, which is denoted by this green boundary. Just to be complete, if you can stop it, it goes black. You can start it, it goes green. So that's in a running state now. And the second flow that we've got here is our generator. I'm going to start that as well. So the behavior of this is to basically go ahead and generate a sample message every 10 seconds, I think. So I'm going to start that, and it'll start to generate some of our sample data. So I'm going to go over to the search screen in the Ikasan dashboard. I'm going to search for wiretaps. So if I press the search button there, I've highlighted the wiretap icon. You can see there the data has started to flow through the service bus. So there's 3 have flown so far, and you can see there more of them are accumulating the longer that I leave that message generator flow running. So I'm just going to stop that from generating messages now. We can have a look. Just if I know it's not really in the scope of this particular tutorial, we can inspect the data that's hit the service bus here. So you can see that it's a very, very simple XML It's got an ISIN in there. It's got a trade identifier which is generated randomly. You can see what component the wiretap was generated. You can see when it was generated, and it's also got an identifier which is unique to each event. So now we're going to look at the behavior of a flow and the way it interacts with the hospital service. So if I come back over to the trade flow that we've got here in the Murex trade module, I'm going to go into our broker and I'm going to configure it. And the first thing I'm going to do is tell it that I want to generate, I want the hospital service to put this particular flow into a recovery state whenever messages hit this particular flow. Now, we've discussed already that a flow might go into recovery if there's a technical exception occurred, right? We can't connect to a database, maybe we can't even connect to our messaging system, or we can't make a call across the wire to a HTTP service that might be exposed. There's a whole range of examples. They're just a few of them that I've outlined there. Now, in order for that configuration change on this broker component to take effect, I need to stop and start this flow. It's in a running state there, so it's happily running, but there's no data on the wire. So this is not going to go into a recovery state until a message hits that particular flow. So let's start our trade generator to generate the sample data. We'll come back over here and have a look at what's happened to our flow. Okay, now we can see the color around that has changed to an orange, and that denotes the fact this flow is in recovery. We can also come over here and we can look at the error reporting component of the search screen, and it's a hospital service that reports those errors. And you can see here that we've got some errors there now. So you can see here that this exception generating broker has generated an error, and it says that the error is an endpoint exception, and it's got a simple message that says the exception is thrown to test recovery. And I can also see that there's a packet of data that's associated with that as well, and that's one of our trade messages. So I'm able to see what's caused this to go into recovery. Now, you can also see that it's got a delay of 10 seconds and it's retrying indefinitely. So if I hit the search button again, because it's retrying every 10 seconds, it's generating a new error every 10 seconds based on its retry interval. So that's going to continue retrying until that particular exception case goes away. I'm going to stop our trade generator. And I'm going to go in and I'm going to reconfigure well, actually, I'm going to go one step further. So if we have a look at our wiretaps, there will have been some messages that have backed up there because the flow is in recovery. I'm just going to go over here and search the wiretaps. You can see we've got 14 wiretaps there now. What I'm going to do is come over here. I'm going to configure this component and say that it's no longer going to throw a recovery exception. I'm going to stop it and start it for that new configuration to take place. And you can see that the flow there has now started successfully. It's happy, it's green, and we're just happily running. I'm going to come back over to the search screen. We can see prior to me starting that flow that was no longer in recovery, we had 14 messages that have been wiretapped. If I do a search there now, we've got 51. And that was because there were messages that had backed up while that flow was in recovery. Once that technical exception was remediated, or in this particular case, once I removed that mock scenario from the component, the data then started to flow. So that's the first example of the way the hospital service works when exceptions have been configured to put the flow into a recovery state. The next exception that we've been talking about is ones where messages get excluded to the hospital service. So I'm going to save that configuration to say that it'll throw an exception to exclude messages. I'm going to stop and start that particular flow so that it picks up the configuration change. So we're running again, and I'm going to start our trade generator flow. Actually, the first thing I'm going to do is just go over here. We're going to look at to see if there are any excluded messages in the system, and there aren't. So I'm going to start our trade generator flow, and it's now generating trades. Now, you can see here our trade consumer flow is still in a running state because it doesn't go into recovery, it doesn't go into an error state, it's still receiving data, but what it's doing at this point here when the exception is thrown, it's excluding those messages. If I come back over to our search screen, you can see now we've got some excluded events starting to appear. So I'm going to stop our trade generator because I don't want to continue to do that. Let's go back to our search screen, and you can see that we've got 13 events that have been excluded. No, it's still growing. We've got 15 events that have been excluded. And we've got 51 wiretaps. So this is now a demonstration of how once we've identified that there are events that are excluded, we want to be able to do something with those events. We still want that data to flow. We need to go and fix some data in an external system perhaps, or we need to do something that's going to allow this data to flow when we're ready to resubmit it. So I'm going to come back over to our trade consumer flow. I'm going to go back into our component that has caused those events to be excluded, and I'm going to flag that so that it no longer excludes messages, and I'm going to stop and start that flow, and we're back in a running state. So this flow is now ready to accept data and let that data flow to its target destination, and it'll also be wiretapped when it hits that destination. So we saw we had 51 wiretaps, we got 15 messages. Now I can resubmit these excluded messages in two ways. I can either select them all and go ahead and resubmit them all, or I can select them individually. So the first thing I'm going to do is just take the oldest message, and I'm going to resubmit that on its own. So I'm going to add a comment. Comment could be a JIRA identifier from a ticketing system, for example, or some other system that you use to manage issues within your organization. So if I resubmit that, you can see here that the excluded message count has dropped to 14. If I go back over here and look at our wiretaps, you see we now have 52 wiretaps. So that message has been resubmitted back into the service bus and has now successfully flowed through that particular flow. I'm going to come back over here and search for our hospital events again. And this time what I'm going to do is I'm going to resubmit them all. So I select them all, resubmit, I put in a comment, and I hit the resubmit button. And there we go. We've no longer got any excluded events in the system. It tells me that I've successfully resubmitted 14 events. If I come back over here to the wiretap, I should see that we now have 66. What do we got? 66. Maybe a couple more as it moves. So 66 messages. So that's our 51 plus 15 is 66. So we've now successfully resubmitted all of those excluded events, and the hospital service has successfully performed its function. Now there's one other scenario here that I'm going to demonstrate, and that is when data flowing across the wire causes the flow to go in and stopped in error. So I'm going to save that. I'm going to stop and start this flow. We're in a running state, and then I'm going to go back to my trade generator, and I'm going to submit or start that flow so some data flows across the wire. So that's started now. Some data will have flowed. I'll stop, come back over to our other screen, and you can see now that this flows in an error state. That's denoted obviously by the red boundary around the flow. But under the covers, Ikasan will have also created a notification via the monitoring service and notified any interested parties that have been configured to receive notifications that the flow had gone into an error. An example of those notifiers would be an email may have been sent to anyone that's interested in that particular incident, such as a support team. Also, an event could have been sent to a monitoring system or a monitoring dashboard, for example, Grafana or Prometheus or something like that. And that would flag that to a system operator, and they would know that some attention is needed to this particular flow. Once again, if I go back in and reconfigure that component so that it's no longer stopped in error, if we come back over to our search screen, we've got our 66 wiretap events, still 66. I restart the flow that's in an error state. It's configured now to be allow data to flow, and we can see that our trade count has now gone up to 68 because there are 2 messages backed up on that particular messaging queue that we're subscribing to. And now that the error state's been removed from the flow, the data's been allowed to flow successfully. So that provides us with some kind of view of how the Ikasan Hospital Service works within the Ikasan dashboard. And really it provides us a robust way to manage different kinds of exception scenarios that occur within the service bus. Allows for business continuity, it allows for full visibility on any errors, and it allows those errors to be managed from within the dashboard across the entire estate. So hopefully you found this tutorial useful, and we'll see you in the next one. Well, thank you very much for tuning into Ikasan Online Tutorials. If you'd like further information on the Ikasan Enterprise Integration Platform, go to github.com/Ikasan EIP. That's lowercase ikasan uppercase EIP. All the links will be in the descriptions of the videos associated with the Ikasan Online Tutorials. And if you've liked what you've seen today, please subscribe to the Ikasan Online Tutorial YouTube channel. We'll see you next time.